Reduction to pinocol. Ketones on reduction with magnesium amalgam and water is reduced to symmetrical diol. Symmetrical diol, that is named as pinocol. The symmetrical diol is named as pinocol. The name itself we know diol. Di means two, OL it indicates OH group. So in pinocol we must have two OH group and they use the word symmetrical. So if we break the molecule into two parts, the two parts should be same. So it is named as symmetrical diol. It is also known as pinocol. Let us move to the chemical reaction. We are taking here acetone. Two molecules of acetone. Two molecules of acetone. It undergo chemical reaction and in the presence of magnesium amalgam Mg and Hg and water molecule we are getting pinocol. How the chemical reaction is happening? Let us move here. C double bond O. C double bond O, how it become OH? This C double bond O, it become OH. Here also it become OH. So we are getting pinocol. Instead of O we are getting OH. Instead of O we are getting OH. That's all. There is addition of two hydrogen. One hydrogen to one acetone. Another hydrogen to another hydrogen. The cleavage of double bond is happening. One bond is joined with hydrogen. Another bond is joined with another acetone group. That is the reason we are getting pinocol. Here the IUPAC name 2,3-dimethyl butane 2,3-diol. 2,3-dimethyl butane. How 2,3? 1, 2, 3, 4. We have 4 carbon. So butane. In second and third carbon we have methyl group. So dimethyl. The same 2 and 3 carbon we have 2 OH group. So it is 2 OH group. So 2,3-diol. So what is the name? 2,3-dimethyl butane 2,3-diol. 2,3-dimethyl butane 2,3-diol. It is pinocol. It is diol. So we understood in second and third carbon we have OH group. So it become diol. They use the word symmetrical. They use the word symmetrical. If we divide the molecule into two portions, here if we cleavage the CC bond, what is the molecule? It become CH3OH in right side and CH3OH and also in left side. Both in right side and left side we have the same molecule in cleavage. So it is named as symmetrical diol. It is also named as pinocol. Haloform reaction. The acetaldehyde and methyl ketone is containing CH3C double bond O group. CH3C double bond O group. CH3C double bond O group. When treated with halogen and alkali give the corresponding haloform. When treated with halogen, they give its corresponding haloform. This is known as haloform reaction. Let us see the example. Now we take the acetone. It reacts with 3 molecules of chlorine. 3 molecules of chlorine. In the acetone is react with 3 molecules of chlorine. We are getting the haloform. How? The first, in the 3 molecules of chlorine, 3 chlorine is react with, it is replaced by hydrogen. So CCl3, C double bond O, CH3. The remaining Cl, 3Cl, it combined with replaced hydrogen and the byproduct we are getting 3HCl. Then the same, it treat with sodium hydroxide. This hydrogen is combined with CCl3 portion and O, Na, it combined with C double bond O So what is the product? CHCl3 and CHCl3 and CH3C double bond ONA. So the corresponding acetone, it gives its haloform CHCl3. So aldehydes and methyl ketones containing group CH3C double bond O group, when they treated with halogen, here we treat with chlorine, we are getting haloform in presence of alkali. Now we are going to see the reactions involving alkyl group. In aldehyde and ketone, we have alkyl group. How the aldehydes and ketone they involve in the reaction? First reaction is aldol condensation. Aldol condensation. What is aldol? The name itself we came to know. ALD is aldehyde, OL is hydroxyl group. So there should be the presence of aldehyde and hydroxyl group. Let us go to the reaction. The carbon attached to carbonyl carbon. The carbon attached to the carbonyl carbon is called alpha carbon. And the hydrogen which is attached to alpha carbon is called alpha hydrogen. The hydrogen which is attached to a carbon is called alpha hydrogen. In presence of dilute base like sodium hydroxide or potassium hydroxide, if two molecules of aldehyde or ketone, having alpha hydrogen, they are together to give beta hydroxyaldehyde. Beta hydroxyaldehyde, that is aldol, or beta hydroxy ketone, that is ketol. If aldehyde involved, we get aldol. If the reaction is with ketone, we are getting beta hydroxy ketone. So we must remember what is alpha hydrogen and what is alpha carbon. So what is the aldol, children? The combination of the compound which contain both the aldehyde and hydroxyl group, that is alcohol group. So it is named as aldol. Now we move to the aldol condensation with a suitable example. When acetaldehyde warmed with dilute sodium hydroxide, it gives beta hydroxybutanaldehyde. Beta hydroxybutanaldehyde. Its name is acetaldehyde. What is the name? Acetaldehyde. Now we move to the reaction. We took two molecules of acetaldehyde. CH3CH double bond O. Two acetaldehyde react with dilute sodium hydroxide. We are getting acetaldol. What happened here? The acetaldehyde CH3CH double bond O. There is a cleavage of double bond and this hydrogen is joined with O. So we are getting acetaldol. Now we move to the alpha carbon and alpha hydrogen. What is alpha carbon? The carbon which is attached to the carbonyl carbon. Where is carbonyl carbon? Here in the aldehyde group we have carbonyl carbon. It is first carbon attached to the carbonyl group. So it is named as alpha carbon. The hydrogen which is attached with alpha carbon is named as alpha hydrogen. It is named as alpha hydrogen. So this reaction take place in presence of alpha hydrogen. In acetal, then it is named as 3-hydroxybutanol. It is named as 3-hydroxybutanol. Another name is beta hydroxybutanaldehyde. Beta hydroxybutanaldehyde. How beta hydroxybutanaldehyde? Which is beta carbon? Here alpha. This is beta. The OH group is attached with beta carbon. So it is named as beta hydroxybutanaldehyde. Let us see the IUPAC name. How we got 3-hydroxybutanol. 3-hydroxybutanol. Let us name 1, 2, 3, 4. How many carbon? We have 4 carbon. I hope you remember. Give the number to the compound. compound. The CHO group, we start the numbering with the functional group. So CHO first, CH2 second, CH is 3, CH is 3, CH3 is 4. The third carbon, the OH is attached. The third carbon, OH is attached. So 3-hydroxybutanol. 3-hydroxybutanol. The IUPAC name of acetaldehyde is 3-hydroxybutanol. Mechanism of aldol condensation. The mechanism of aldol condensation of acetaldehyde. Aldol condensation of acetaldehyde. It takes place in 3 steps. How many steps? 3 steps. What is the first step? Formation of carbanion. Formation of carbanion. What is carbanion? The carbon, it become negative sign. That is anion. The carbon, it become anion. So it is named as carbanion. How it become anion? As the alpha hydrogen atom is removed as a proton by the base. As a proton by the base, the carbon atom, it become anion. So first step. I hope you remember what is the base we are taking in this reaction? Sodium hydroxide. From the sodium hydroxide, we are getting OH minus. This OH minus approach the alpha hydrogen atom. So in alpha hydrogen atom, it remove as water along with the OH minus. Water along with the OH minus. So the CHO, it become negative sign. There is a formation of carbanion. This is the first step. As the alpha hydrogen atom is removed as the proton by the base, we are getting carbanion. In step 2, this carbanion attack the carbonyl carbon of another unionized aldehyde. Carbonyl carbon of another unionized aldehyde. We already know in this reaction, we are taking the 2 molecules. In first molecule, there is a formation of carbanion. This carbanion attack the second aldehyde, particularly carbonyl carbon of another unionized aldehyde, to form alkoxide ion. Formation of alkoxide ion. The carbanion which is formed in first step, it approaches the carbonyl group of second aldehyde. So the double bond O, it become O minus. This is the alkoxide ion. What is alkoxide ion, children? The alkoxide ion is an organic functional group which is formed when a hydrogen atom is removed from an hydroxyl group of alcohol. What is hydroxyl group? OH is a hydroxyl group. In OH, there is a removal of hydrogen. So we are getting O minus. Commonly it named as RO minus. It's a alkoxide ion. This alkoxide ion formed is protonated by water. This is a step 3. The formed alkoxide ion, it is protonated by water to form aldol. How protonated? In water, it become H plus and OH minus. In the water, it become H plus and OH minus. This H plus, it adjoined with the O minus, alkoxide ion. So it become hydroxyl group. We are getting 3-hydroxybutanol. This is aldol. 3-hydroxybutanol. So we are getting aldol. Let us recall the mechanism of aldol condensation. In step 1, formation of carbanion. Step 2, formation of alkoxide ion. In step 3, formation of aldol by protonation of alkoxide. Then the aldol rapidly undergoes dehydration. What is a dehydration? Removal of water molecule. The aldol rapidly undergoes dehydration on heating with acid. As a result, there is a formation of alpha beta unsaturated aldehydes. Alpha beta unsaturated aldehydes. Here, this aldol, there is a removal of water molecule from alpha carbon and beta carbon. What is alpha and beta carbon? This is alpha, this is beta carbon. Alpha and beta carbon. There is a removal of water molecule. So we are getting unsaturated. What is unsaturated? In the common there should be any double bond or triple bond. Here, on because of the water molecule from alpha and beta carbon, there is a formation of double bond in second and third carbon. So CH3, CH double bond, CH, CHO, crotonaldehyde. What is the IUPAC name? We have 4 carbons, so but. In second and third carbon, we have double bond, so 2. Because of the double bond, En, and in presence of CHO, Al. So but 2 enol. This is the IUPAC name of crotonaldehyde. So we understood the aldols rapidly undergoes dehydration. Because of this, we are getting unsaturated aldehyde. Unsaturated aldehyde. This is a mechanism of aldol condensation.